This is a climatograph. It's really useful and easy to make. I made this in about 10 minutes. This invention helped me today in a real-life scenario. I got to measure the height of my basketball net, and I'll show you how I did it. But first, I'm going to show you how to find the height of an object using their shadows. The first thing I did is measure the basketball net's shadow, which was 10.6 feet. And then I measured the height of myself, which was 6.2 feet. And then I measured my shadow, which was 4.8 feet. I calculated the height of the basketball net by taking 10.6 divided by x equals 4.8 divided by 6.2. And then I cross-multiplied, giving me 65.7 equals 4.8x. So you divide both sides by 4.8, which gives you approximately 13.5. And now moving on, this is how you use the climatograph to find the height of the basketball net. First you take the angle that the climatograph gives you when you look through the straw. When you look through the straw, the string is going to change, and wherever that touches, and the angle that it's on, that's the angle of elevation. So in my case, that was 60 degrees, and then I had to measure the distance from where I was standing to the basketball net, which was 10.6 feet. And the height from my eyes to the ground was 5.8 feet. And yeah, using the results I found using the climatograph, I used tan x equals L over h, and I reordered it, giving me h equals 10.6 over 1.7. 1.7 comes from tan 60, so h equals 6.2 feet, and that is from my eye level to the top of the basketball net. All that's left to do now is find the full height of the basketball net. All I need to do that is find the height from my eyes down and add that to my original answer, and that will give me the full height. So the formula is h equals L over tan x plus d, d being the distance from my eyes under. So it's h equals 6.2 plus 5.8. The overall height of the basketball net is going to be 12, therefore the height is 12 feet. Now you may notice the answers are different. That is only because I took the observations at slightly different times, meaning I measured the shadows. I'm not sure the exact time difference, but all I know is that there was a bit of a time difference because of the rain. But anyway, I subtracted, I think it was 1.4, because those were the differences, because it was the low option. I did try the high option, but it wasn't giving me a close enough result, so I ruled that out. But I took the higher option, the lower option I mean, giving me a shadow of 4.8, and that gave me 13.5, which is somewhat close to 12. So I'm sure if I did take the shadow measurements at the same time, I would have gotten a common answer. But with that being said, that concludes my presentation. Thank you all for watching, and I hope this gets 1 million views and I become famous. But just a couple things before I go. Couple questions here. How did you find the activity? I found the activity was fun and a good way to show how math can be used in the real world. The most exciting part of the task was taking my math skills outside and discovering how I can incorporate them into my day-to-day life. What mathematical insights did you develop? I learned many ways of doing math that I wasn't confident before taking this or doing this. So I'm thankful that I'm more confident now. Any other comments you might want to add? Say thank you to Miss Arana for all the extra help she's given me and helping expand my knowledge and everyone else's, and showing everyone how to make a climatograph and how everyone can use math in their day-to-day lives and how it can be useful, and I am very thankful for that, so thank you.